This website is Tinker CAD. They have a lot of different options for components, but today we're just going to be doing a 3D design for a 3D print model. So we're going to start off with a cylinder and put that in the middle. Click on the top view in the upper left-hand corner. And that button on the bottom just makes it a little more accurate for designing purposes, but not as realistic. And if you click anywhere in that plane with all the boxes, you can change the view of the object. So by clicking up top, we can resize it by entering it in. I'm going to put 0.25 inches because that is the diameter of the Permobil stem. If you pull up your joystick on a Permobil, there's that little metal thing that's under there, and that's a 1/4 inch in diameter, and there's about an inch before that little protective shroud starts showing. So I'm going to make it a little bit larger than an inch. You'll see in a second. Center it again on that middle of the work plane. And then I'm going to click the center button right there, which is going to put the object right in the middle, make it easier to design. So this bevel just kind of rounds out the edges. I'm going to put a little bit of a bevel. It'll make it easier to go on. The joystick will go on the stem easier. And there's a little bit of a bevel if you remove the joystick. Then I'm going to turn it to whole, which is going to deduct all of this at the end of our design. I'm going to make that just a little bit longer. I think the snap is 1/8 of an inch at the bottom, so whenever I drag, it'll kind of click to that. So it's 1 1/8 inch long now. So if I put another cylinder right on top of it, you'll see it kind of places it on that other object. So what I like to do is put it next to the object and then drag it over, which you'll see in a second. There we go. And now that hole will be going out of the bottom a little bit more than the object, which is why I made it 1 1/8 inch. But this I'm going to make 1.25 inches, the actual material. The sides just make it smoother. You can't get a perfect circle with a 3D printer, but you can get it to the closest 0.4 millimeters, which is pretty darn close. Now I'm going to put an oval at the top. I'm going to make a circle and just grab those sides, those little black squares on the edge, and drag them. So this is 2 1/4 inch wide, I believe. The reason I'm making this joystick is it's not only cool and fun to do, but when I was backing out of my bathroom, my goalpost joystick that was on my Permobil was actually wider than the joystick module itself, which is about 3 inches wide. So it actually caught the cupboard in my bathroom and pinned my arm against the wall in my wheelchair, and I almost got stuck there. So this is actually pretty functional. I was in desperate need of a joystick that was not wider than the module, so that wouldn't happen again. So these two surfaces are, when they were flush with each other, you'll notice when I put them on top of each other, there's a little bit of a line that forms when two materials become flush with each other. So I'm going to make it a little bit taller than the other cylinder, just so that doesn't happen. Sometimes it causes a problem with printing. Other times it doesn't really matter, but just to be on the safe side, I'm going to actually have that oval just a little bit taller than the cylinder that I first drew. And now that they're all centered with each other, I'm going to make that cylinder, that little stem, a little bit smaller. An inch is a little bit too big. I do want to be able to get my fingers around it, so I'm just going to make it a 1/2 inch wide. So if the hole is a 1/4 inch and the stem is a 1/2 inch wide, then a 1/4 inch of material should be pretty strong. If I break that, I think we have bigger problems, but should be okay. So this is pretty much the basic design. There's obviously a lot of customization that you can do, but we're keeping it pretty simple just for an introduction to 3D modeling. Here you see those two surfaces kind of not perfectly forming into one another. So if you're making a design like this, you can add any sort of customization you want, obviously. But what I'm going to do is I'm going to make 2 additional ovals on either side, and I'm going to turn them into holes to kind of create a groove that will hopefully keep my hand from slipping off if I'm maybe going around town or over some bumps. So I'm clicking on that hole button again in that drop-down menu. And now all we have to do is combine all of these objects that we drew. So we're going to click each one. And for some reason, it's not letting me click that last hole that protrudes out the bottom of the plane. So we're just going to combine these 4 objects. Use that union button right there, which just means we're uniting them all. And then we're going to join those 2 other objects. And there we go. Then last thing to do is rotate it upside down. This is for printing. Generally speaking, 3D printers like to start wide and then print thinner as they go up. So I'm just going to put this whole thing upside down. If it was printing the other way, it would create these little filaments to support that large T handle. And then you'd have to cut them off, so it's easier just to put them upside down. And it automatically generated some random name, so we're going to rename this Permobil U handle. I think I originally put T handle, but it's kind of like a W or a U. You can call it whatever you want. Could have kept the automatic name generator if you wanted. I'm going to click over there to export, and an STL file is the most generic one. There's some that do others, but we're just going to save it as an STL file. And on my iPad, everything pops up right here. I can sync it with my iCloud drive, and then I can access it from my PC. All of this Tinker CAD I was doing on my iPad, but it's browser-based, so you just go to tinkercad.com, and you can access it from a PC or possibly your phone. And there it is. So you can just send these STL files around. There's 3D printing at the Richmond Public Library, as well as print farms around the states. There's some places that will actually print for free if it's an accessibility device, and I'll try to get some more resources on that for next time. But yeah, the STL file you can send off to pretty much any sort of 3D printer, and they'll print it out for you.